Hello everyone, I am Dr. Rituraj Dubey, BNM College Badaya. Today we will discuss Pinacol-Pinacolone rearrangement. It is an acid catalyzed dehydration of glycols. Glycol means 1,2-diol, which converts the glycol into an aldehyde or ketone. So the simplest example is here. This is called Pinacol 1,2-glycol with methyl substituent in both the carbons, reacts in presence of concentrated H2SO4 and heat. With heat it gives pinacolone, where you can see CH3 is on the same carbon and one carbon is converted into ketone, aldehyde or ketone. Product will be aldehyde or ketone, so it is called as pinacolone plus H2O. Now let us discuss the mechanism. I have written this structure in line structure formula. This is CH3CH3, this one is CH3CH3, OH. Now you can see concentrated H2SO4 will give H plus ion, so this lone pair will take H plus ion, so it converted into H2O, and this water will be released in second step. You see here, so there is a positive charge created. Now in this next step, CH3 will migrate from here to here. Why? I will tell you later. After migration, this you will find this product, which is resonance stabilized with this, because this lone pair will go down and convert this one positive charge. So this gives two resonating structures. That's why this stable carbocation converts into another carbocation. These are resonating structures. Now in next step, the water which has been released in the first step here attacks on this proton and takes it. So minus H3O plus, and this is a pinacolone, a ketone with substituted side chain. Now what are the factors affecting Pinacol-Pinacolone rearrangement? First, stability of carbonium ion, means the reaction proceeds in that direction in which the stable carbocation or carbonium ion will be generated in the first step. Now you see in this molecule there are two types of carbon which is attached with 1,2-diol. You see here CH3 means two CH3 are substituted with this carbon, and two pH groups means phenyl group is attached with this carbon. So both the carbons, this one and this one, are different, so both will give two different types of carbonium ion. You see in the presence of concentrated H3, when it reacts with this OH and it will remove the water, carbocation will be generated here like this. And in another case, when H plus attacked with this this OH take proton, so after removal of water, carbon positive charge will be created at this step, so it will give this carbonium ion. You see, if we compare these two carbonium ions, you see this one is more stable than this, because here positive charge is adjacent to the two phenyl group carbon, and here positive charge is adjacent to the two methyl group, so this one is more stable. So the reaction proceeds through this step, and after this step the rearrangement takes place, and CH3 will go in at this carbon, and this will convert it into ketone. So the product will be PH CH3C, and here double bond O and CH3. Now another factor which is affecting Pinacol-Pinacolone rearrangement is migratory aptitude of the group. Suppose both the carbons two carbons adjacent on which OH group are attached are equivalent. In that case, in second step predominates, where migratory aptitude of the carbon group decides the final product. You see migratory aptitude of different groups here, H minus. You see in this mechanism, the group functional group CH3 moves along with the bonding pair of electrons, so it is always a carbanion. So H minus is greater than pH minus, is greater than 3 degree carbanion, is greater than 2 degree carbanion, is greater than 1 degree carbanion, is greater than methyl carbanion. Now take an example. You see here two carbons, both are equivalent because in this carbon one substituent is pH, another is CH3. You see pH CH3. So after attack, what will be the product? Both carbons are different, so carbonium ion will be same. So suppose here positive charge is created, any one positive charge created after removal of water. So there are two groups, we can migrate from here to here. So in this case, migratory aptitude, you can see pH minus migratory aptitude is far larger than methyl carbanion. So pH along with bonding pair of electrons, it will move to this carbon. So and this will convert it into ketone. You see CH3 COOH, and pH moved with here. So pH CH3, pH CH3. So product will be this. Another factor which affects Pinacol-Pinacolone rearrangement is intramolecular migration. Means when a mixture of two different pinacols are heated in presence of acid, no cross product is formed. What is the meaning of cross product? Let's see. Suppose in a reaction vessel, we take this pinacol and this pinacol. So the product will be not mixed with this one, means the migratory aptitude of CH3 will not migrate from here to here or from here to here. So this will give one product and this one give one product. So mixture of products we can get, but from two reactants we get only two products, not more than two products, which is from which will be formed from cross migration. Means migration of a group from this reactant to this, or migration of group from this reactant to this. So these kind of cross product will not be formed. And fourth factor which is affecting Pinacol-Pinacolone rearrangement is steric effect. Means if there is an steric effect, it always matters. So in this way you can see that this group where these are para substituent migrates faster than this group where these two are ortho substituent. So this will give the product as migratory aptitude, but this will not, or it will give a minor product. So that's all for now. We will meet on another lecture on another day. Thank you very much.